All right, welcome back to another quick tips session from PowerBI.tips. We're going to do another exciting video going deeper back into Spark. We're going to talk about security and optimization. And with me, I have two incredible Microsoft team members with me here. Sharan and Santosh are with me again. We're going to go deeper on Spark. This is incredible. This has been a great series, and the Microsoft team is absolutely crushing it with building creature of life improvements. All the UI is getting better. We're getting so much more features, and Spark's getting faster by the team working on it. So I love the stuff that we're doing here. I think you're going to love this engaging discussion. This is a presentation from Microsoft around security and optimization. Take it away.
Thanks, Mike. Happy Friday, and thank you so much for having us again on the show. So I'm Santosh. I am a senior product manager in Fabric Data Engineering. I lead the Spark Compute and all the enterprise platform capabilities for data engineering workloads. I have with me Shravan.
Hey folks, and thanks, Mike, for having us here. This has been a great series. Love that I watched the other one with Santosh and Ashit. It's really come out nice. Happy to be here. My name is Shravan. I lead the data engineering experience and infrastructure teams. My experience teams build all the notebooks and lake houses, and my infrastructure teams provide all the compute and the required APIs to power the Spark engine. I'm actually representing the hard work of all my team of amazing engineers who have built a world-class product that you all are loving.
I would agree with that statement. It is becoming extremely world-class, and I love the effort and the attention to detail. You're definitely listening to customers here, which I really appreciate.
Thank you.
Thank you so much. So for today, we mainly want to touch on some interesting topics. We have been hearing this from users on various channels through Twitter and on Reddit. So when it comes to last time we talked about how they could actually go from a proof of concept to a production scale workload, right? So today we wanted to double click on optimizing and protecting the data. So when they go full scale, like when they go production with the data engineering workload, the first thing that they would want to make sure is they have compute, their compute is optimized, and it's going to scale based on their workload requirements. So we'll be touching on the capacity in Fabric, which is going to provide the overall compute for all the workloads, and how this ties into the data engineering workload, and what are the throttling and queuing scenarios in data engineering workloads. And we want to also double click on, at the end of the day, you will want to size the capacity based on your compute requirements. How would you go about it? Like if you run into these throttling scenarios, which users might during the peak usage hours. So how would they navigate it? What are the ways, or what are the guidances that we could share based on our discussions or experience from working with other customers who have run into similar challenges? And again, super happy to hear more feedback so that we could go back and fine tune things. And then I would hand it off to Shravan. Shravan is actually going to take us more into the interesting concepts of and the features that we have enabled. You're very much aware. We went recently GA with some of the network security features, which are which have been loved by enterprise customers. And we would also want to walk you through an end-to-end scenario on how all of these would help you build a secure data engineering platform on Microsoft Fabric. So let's get started. Talking about compute, right? In Microsoft Fabric, capacities are the single compute modality which is going to power all of your workloads, starting with Power BI, data engineering, data warehousing, real-time intelligence, all the workloads. So it makes it super simple for any enterprise customer. Capacity is just another resource that they could provision on Azure using an Azure subscription. They could choose capacities based on the sizes, and also based on the region where they would want to manage the resources. Once it's provisioned, it's going to be available in the Fabric tenant, and it's going to power all these workloads. So, say you're an enterprise administrator, or you manage an enterprise data team. You have different teams like data science teams, data integration teams, and you also have data engineering teams. Not In this case, the capacity is going to give you the flexibility where you just provision a single unified building model which you manage, but this is going to like power internally, and it's going to be shared across all your teams, across all of their workloads. So and it simplifies the overall process of building and compute management to start with. And now, talking about different teams and different types of workloads, each and every workload is going to be each and every workload is going to have its own requirements in terms of compute usage. The compute usage for more interactive workloads like Power BI is not going to be the same for like background jobs that run for your data ingestion and data transformation, right? So in the cases where some workloads could basically overuse the capacity, we want to make sure that it still serves these requirements and it helps you scale. So capacity comes with features like smoothing and bursting, which allows you to go over your allowed limits during peak usage hours. So you're still able to like fit in large jobs from Spark, or like your data science or machine learning model based workloads. These jobs are going to be still be allowed. They run during a peak usage hour. They could be short lived, and then they once they are done, rest of the time period that's available in your capacity. Say, for example, it runs for 1 hour every day from 9 to 10 a.m. And there are pockets of inactivity the rest of the day. And so what the capacity model does is it actually allows you to borrow from your future. So think of it more like borrowing from the next 24 hours. So let's take an example of an F64 capacity here, right? Now F64 gives you 64 capacity units. And each and every workload is going to be different. As we know, the BI workloads could be more continuous in terms of usage because they're more interactive. They're going to be used by your data analysts, business users across your organization throughout the day, during the active hours of the day. The data integration and data engineering workloads are more could be more triggered during the off hours, where they are processing the data for the next day's business consumption or aggregation, right? So these jobs could spike up. They could go over the limits, and during the rest of the inactive time periods, these are smooth. So your overall utilization still is within the limit that you purchased with, like, or the SKU that you bought with, right? To simplify this, I know we talked about like the unified compute. We also talked about like concurrently multiple teams using these, and also how this is actually going to serve all these different requirements at different points in time at different scales, right? We were actually discussing this. I was discussing this with Shravan, like how do we make this much more simple? So Shravan actually was suggesting, hey, this is more like a buffet, right? You just an all-inclusive buffet. You just pay for one. You just pay a single rate. Like you don't pay for every meal. You just pay for a single buffet. And in this case, you're gonna either you have a more preference towards desserts. I don't know. I do that sometimes. And or you could go heavy on appetizers, or you could go heavy on entrees. It's up to you, and it's how you feel that day. So similar way, the capacity is gonna not, and also the buffet. At the end of the day, you are, say you have multiple people you having different interests or different workloads, right? So some of the users could be heavy on data science workloads, some of the users could be heavy on Power BI. At the end of the day, as an enterprise data team admin, or like a person who's managing the capacity, once you provision the capacity, what it allows you to is overall you're able to like serve everyone, and also like not overspend or like not lose up on unused usage, or also trying to manage different compute elements at different point in time, like just to cater to data engineers, or just to have a specific supply of desserts in a buffet. You have everything available and users could use it at any point in time, and you just pay a single rate at the end of the day.
I really like this point that you're making here. I think this is actually a brilliant analogy here. I will also argue in some things that I've observed in my clients as well. This is a great point. I love the buffet analogy here, because there is different workloads consuming from our consistent capacity units that we're purchasing. But you'll also notice sometimes, I'm a mechanical engineer by trade. So I love we're talking about the area under the curve, right? We're trying to take all the compute you have, and you may have a spike in compute, but we want to utilize that extra area under the curve where we're not using that high demand. And we're doing a lot of balancing between self-service, high spiking demands in a moment, right? The buffet is swarmed with a bunch of people all at once. We need to be able to support those loads in addition to things get a little bit quieter, right? And so then things settle out a little bit. And so that's where, I would like to reuse that money. It's an investment I've made to my company. One thing also, I'll give you a little trick here that I use with certain companies. When you're in the smaller SKUs, like an F2, F4, F8, you're just starting out. You are going to hit these limits probably more sooner than you think, occasionally, and you may overrun your smoothing for a period of time.
Yeah.
But what I have learned is, if you go in and pause your capacity, it's like going to the register, paying for your bill, and then going to sit back down and start with a clean slate. So what I'll say is, to borrow your analogy here as well, you actually have the ability within Fabric, if you overrun your usages as you're growing your business and you're trying to figure out the balance of the loads, and you actually need to educate the data culture of your team to not overabuse too much of a single spiking event that could consume all your area under the curve for the future. So there's a lot of really great conversations. I'm probably taking away your steam for the rest of the things you're going to talk about, but I think this is an incredibly important note to make here around this concept of, as we start thinking about Fabric, you, the business, have the control to manage it how you need to. And this is very, very helpful for us.
No, 100% agree. The point that you made around the pausing and resuming, right? It's totally valid, and it's something that users have the flexibility to do. So there could be certain times where, and we have seen this in certain enterprise user scenarios as well, like where they actually have very, very short-lived operations, and rest of the day maybe they're just doing a proof of concept. They don't need this 24 hours, right? So in those cases, they do go and pause this, and they achieve a better utilization rate. They control the overall compute utilization, or like the spend that they would want.
Totally agree.
Yes.
Yeah. And I think the capacities were primarily designed to be a billing notion, right? It should be, mostly out of your head. Like, you don't even notice it exists, right?
Yeah.
Unless, of course, it's like the buffet has run out of food, right? Like, you go.
and that's the point here. I guess what I'm also trying to make as well is, us as the admins, right? Yeah. There should be a smaller, very narrow group of people that really are taking close monitoring on this and being very attentive to these capacities and demands. And then those individuals are then able to then educate, bring back that knowledge back to the organization. Hey, look, we may need to divide our capacities into different places so we have reliability in production, and we can spin up other capacities as needed. Sure, overwhelm them, no problem. But then you're isolating them away from your main workloads. So there's just a whole bunch of really interesting strategies that come along with this. And I really love the example you gave here. Solid example.
And it's going to be, as Shravan mentioned, right? So ideally, it's just a billing concept, and you want to make sure that it's simple, and it's also like, it is also flexible for the admins to control. Now, double clicking on like the data engineering workloads, right? So we saw what capacity is, what it does, how it works across all workloads. In Fabric, the Spark compute powers the data engineering, data science workloads. So this includes notebooks, lakehouses, Spark job definitions, and all the Spark jobs that run, which are triggered by pipelines. These are all going to be like coming on the Spark layer. And Spark, as you know, is you have compute options where you could size your compute based on your data requirements or your price performance that you want to achieve. You could go with you could start as a small single node, or you could also go to a XXL node with say 200 executors. It's up to you, right? Now, given this level of flexibility that Spark provides, we want to make sure that users, enterprise users, as part of data teams, they don't run a single job unknowingly, like with a larger compute, which could basically empty the buffet or like take down your entire capacity, right? So in this case, what we have is you have the overall capacity, we saw the utilization and the area under the curve, as you mentioned, Mike. Once you hit the Spark limits, so Spark translates, so for every single capacity unit that you get from a Fabric SKU, you get 2 Spark vCores. So it's 1:2. And what we do on the Spark layer is we have a 3x burst multiplier. So we talked about bursting, where we allow you to go over your actual limit. So taking an example of like F64, right? F64 is going to give you it's 64 capacity units, which translates to 128 Spark vCores. Now, 128 Spark vCores, on top of that, we actually apply a 3x burst. So you get 384 Spark vCores. Now, with 384 Spark vCores, you would be able to like parallelize them. You could run as many jobs as you want. Once you hit these limits, what happens is, if it's going to be, as you're seeing in the GIF right there, you would actually run into a throttling error. So I've heard this from multiple enterprise users. Hey, I'm seeing this HTTP response where I'm throttled. It basically shows that there's too many requests on your capacity. You've exceeded the Spark compute limit. So this happens in the cases for interactive jobs like notebooks or lakehouse operations like loading to a table, right? So you immediately know you're hitting the limit. So you can actually go to the monitoring hub, look at the jobs that you have. You take the call. If you feel that this interactive operation is like super important, you could cancel it, or you could also like bump up the capacity from a lower SKU to a higher SKU so that you could pack more jobs. In the cases where it's more background, say it is more like a Spark job definition or notebooks that are triggered from pipelines or scheduled notebooks, those are going to be like added to the queue. I will be talking more about the queuing part. Before we go into the queuing part, I just want to like refresh everyone about this concept. I did briefly touch on this in our previous episode about job admission. So unlike other Spark platforms, in Fabric, what happens is when we talk about job admission, say you're sizing your compute. In this example, I'm actually having a notebook which is attached to a pool, which has a max nodes of 8. On Spark layer for data engineering in Fabric, we don't reserve the total cores. You have the option to go to a reserve mode, but by default, we don't reserve. Why? Because it starts with the minimum node configuration. So in this case, say it's an F32 capacity. You have 184, 192 total Spark vCores available. First job comes in, it actually it just takes 8 cores away from it. It doesn't take all the 64 cores. So it actually gives you more opportunity for you to like pack more notebooks. And as the jobs scale up and scale down, what happens is and these jobs are like enabled with Autoscale. So I would recommend users to like always enable Autoscale. So the system is able to like do a better job in terms of giving you a better compute utilization across all of your jobs, and not just within that job. So say for example, this notebook comes in, it starts with a one node, it goes to it requires, since it's medium, it's going to ask for 8 cores. What happens is it starts and 8 cores get taken off from your capacity. Now the job is actually running into a task which requires more cores. It's going to ask for more executors to be added to this. So it goes back to the capacity, checks, hey, do I have more cores available? If it's available, then it's going to allow it. Then it actually triggers a scale up. In scenarios where you have too many concurrent jobs across your capacity, right? In that case, what could happen is, say, in this case, all these notebooks, like two of these notebooks are already running at max capacity. Let's take an example. And the third one actually also is running at 8 nodes, but now it's actually asking for 2 more nodes to scale up to its max of like total of 80 cores. The other 2 are like in 64 cores. In this case, given that there's no capacity available, the scale up request is going to be rejected. It's not going to error the job. Like your job is not going to run into errors, or like it's not going to be canceled at any point in time. But it just continues to run in the current configuration of like 8 nodes, 1 driver, 7 executors, and it would scale up once the cores are available. Or like say another job finishes, it gets more cores, then it's going to like scale up. Now, in the scenarios where you have scheduled jobs, right? So we talked about queuing. So these jobs include all notebook jobs that are going to be triggered through pipeline activities. You could have API-based notebook jobs, or notebook jobs that are triggered by schedulers, and table maintenance job, like if you want to do optimize, which you run on Lakehouse tables, and Spark job definitions. All these are going to be added to the queue. The queue sizes are based on the based on the Fabric capacity SKU that you purchase, and the queue expiry is 24 hours. So a job is the jobs are going to be available in the queue since the time that they were submitted for 24 hours, and after that they would expire. They would have to be resubmitted. In the cases where, say, the same example that we saw earlier, say if there's one total of 192 Spark vCores available, say all of these jobs have already scaled up to its max node configuration. There's no room for the 4th job that's coming in. Then what happens is it gets added to the queue on the Spark layer and gets automatically retried. So when, as we saw on the previous screen, in the GIF, when the jobs are in queue, they would actually be in the not started state when you look at the monitoring hub. We touched upon like 3 different topics, right? We saw how job admission works. We also saw how throttling works and why do we have throttling and what are the limits, and also the throttling and queuing on the Spark layer. Now, the common question that I always get from customers is, okay, how do I pick the right capacity, right? It's not going to be a one size fit all. Like it's going to be completely dynamic based on your data engineering usage, based on your Spark jobs. So usually users hit this. They start with, like as you mentioned, they start with smaller capacity SKUs like F4 or F2, or if it's they have more concurrent usage, they usually start with F64. I've seen users move from trial directly to like F64 and or higher SKUs. Generally, when they hit the throttling limits, what users do is they actually go and check the capacity metrics app, which is the single pane for you to like understand your overall usage and the capacity consumption from all the other workloads. not just data engineering, right? Across all Fabric workloads. So in that, when users usually go, they see that the usage is not hitting the max limit. They see this line where the line is still below the curve. So they get thrown out. They're like, okay, but my utilization is still below its limits. Why am I being throttled? Um, so the reason is the capacity, the Spark compute limits, and the bursting behavior that I mentioned, right? So when users actually see this, I would recommend them actually to go and look at the monitoring hub, which is going to show the actual number of jobs that are running. You can add a column called allocated resources from the column options. That's going to show you the total resources that are being used. And that's also going to give you a good sense of like the max vCores that you need. And once you have the max vCores, you'll be able to map them to the right SKU based on your Spark compute limits. Like the concurrency limits are available in our documentation, so you'll be able to like finalize on the absolute maximum that you'd want to like have on your Spark jobs, so that your jobs don't get queued. There are other options where once you define the max SKU, the max compute limits based on a Fabric SKU, you could still achieve a better compute utilization, where not all resources are going to be, not all jobs are going to be using all the resources, or they're not going to be running at 100% utilization in some cases. So in those cases, you could leverage features like high concurrency mode, which we talked about, like Ashit explained it in the previous episode. Different options for high concurrency mode, both interactive and the scheduled ones, where we actually have options for targeting notebooks using session tag that was recently announced. So you could use those to actually have a better session sharing and better compute utilization and performance across all of your data engineering workloads. So with that, I would actually want to like hand it off to Shravan to cover the security in Fabric data engineering.
Hey, thanks, Santosh. I think that was a great intro to all the the capacity and the throttling aspects of it. Just to recap, I think like a well catered buffet, we try to manage most of the workloads like with smoothing and bursting, so that the workloads that our customers have can run without any glitches, right? And I think you've shared a great set of tips for folks to kind of like keep a tab on how things are proceeding. And I think I would say monitoring hub is one's best friend. Like if you're running into any of these issues, I tend to just like anytime I see this, just pop in there and then see what's going on, right? So that's a really cool feature that I think everyone should get familiar with.
I'll give a little quick pitch to Monitoring Hub as well, especially for organizations that are growing into this and they're starting small and looking at building bigger things. You'll find sometimes on those smaller SKUs, you may run into an error where it says, hey, wait a minute, we have an API issue. You've been throttled for some reason. So where I go the first place every single time, let's go into the Monitoring Hub. Oh, wait a minute, I had 3 or 4 notebooks open. I don't need these other 2 notebooks. Let me go shut down those sessions, releasing my cores, giving me back what I need, and then I can go start my new notebook and do my run job. So it's very helpful to know that it exists. And if you are getting errors or any kind of things that don't seem normal to you, definitely go there, check it out. I highly recommend it. And it's nice that it's centralized. Everything running in your environment shows up there, which is great. So really good design on that as well. Nice job, guys.
Thanks, Mike. Awesome. Cool. So okay, I think like, security is one of those things that you would want to, do right. Many times it's actually configured by admin, so you don't notice it. So it's kind of like, going to touch around some of these admin aspects. But I think as users, I think it will be great to know, like, what is happening behind the scenes, right? And then how can we get unblocked? Okay, so let's talk about security in data engineering for Fabric. Um, Whenever like I think of like security architectures, right? So I uh, imagine like these old fortress cities. I think it's getting a bit heavy on the analogies, but bear with me, right? So think of like having these outer walls and moats, gatehouses and drawbridges, inner walls, and finally like the keep where you put all your like valuable assets, probably like your king and queen are there, which is like the last line of defense, right? So similar to that, I think security is always implemented in layers, right? So you start with perimeter security, you then think about access control, and then you finally think through like, hey, how do you actually secure the data that you have, right? And to top it all, right, like as guards, like patrols and watchtowers are critical for safekeeping of cities, or at least were. Security monitoring through some kind of like audit events and incident response is crucial for anybody in today's like modern threat landscape to watch out for, right? And all of these mechanisms are available in Fabric, and we will touch upon most of these as we go through the slides. Cool. So let's start with the perimeter security aspects, right? So the the first thing you would want to do is like set up isolation for your environments, primarily because most attacks start with like someone anonymous from the public internet trying to kind of like infiltrate, like try to snoop around. What can they do? I think if you can just start with blocking that all, right, like I think it significantly reduces any kind of like a lot of those risks that you get by exposing your infrastructure to public internet, right? So a great feature that Fabric offers is network isolation, right? And we have this notion of a managed VNet that kind of like helps implement some of this network isolation. So um, how does someone enable this managed VNet feature, right? So I think there are a couple of ways. One is, I think, if you want to block public access as a tenant admin, you can go ahead and then activate private links, right, through the admin settings. And once you do that, right, and there's also like a small toggle which says, hey, do you want to block public access? And once you do that, right, so connections to your Fabric tenant will be restricted to VNets that have Fabric private endpoints provision, right? And like you can see in this GIF, once that is done, like any attempt from public internet for anonymous access, or even like if they could be in your organizations, but if they're not within these trusted networks, and the traffic is not coming over a private link, then all of those traffic will be rejected, while the trusted traffic, which is coming from, hey, this is my secure network and I know it's protected, there isn't anything malicious in there, so that will still be allowed, right? I think this puts that nice kind of like moat around your infrastructure, and then the private links are similar to those drawbridges and petrol houses where you have like folks guarding the entrance to your fort, right? So that's a really nice feature, I think, for anyone who is like security conscious. The next thing that I wanted to highlight is managed VNets, which are essentially like VNets that are deployed on the Microsoft infrastructure to protect the Fabric assets that you deploy. They are actually completely managed by Microsoft. You don't have to kind of like deal with these networking infrastructure. This is always hard, right? So Microsoft has decades of experience in dealing with security and networking and the configurations of that. So it comes in with like a default secure model that works for most of our customers, right? So the moment like someone chooses that they want to either like block public access or use managed private endpoints, we then start to provision all your Spark workloads into a dedicated VNet. So before you do that, if it is like public access allowed, and you don't have any kind of like private endpoints that are provisioned, your Spark workloads are actually running in VNets that are shared with other tenants and other customers. I mean, not to say that they are less secure or anything. It's just that it's not like completely isolated, right? So there are like NSG rules and others to make sure there is no like cross traffic, right? It's a multi-tenant system. But for someone who's looking for like, hey, that last level of security where I don't want to be in the same VNet, I want to be like fully isolated. I think that's where you get this option of like being provisioned into a dedicated VNet, which allows like each workspace to be isolated, right? So every Spark resource that gets provisioned actually gets it in a workspace, gets its own like VNet, and then like other tenants or other workspaces in the same tenant will not be able to access those, right?
Now,
So
quick question around this a little bit. Now,
yeah.
where's the cost come from in this? So I know managed private endpoints comes with a little bit of additional costs when you're going from that's like my organization into all the things that are Azure and the goodness that is there.
Right.
Where does the cost come from in the managed VNet inside the workspace? Is that included with your Fabric SKU? Can you maybe speak on that just a little bit around, because there is some considerations here on cost-wise parts of this architecture. Maybe you could speak to that a little bit as well.
Yeah, absolutely. I think like Santosh can probably dig into the cost aspects a little better, but I think right now like we are actually offering all of that as part of the Fabric cost, right? So it is not something that's charged extra, right? Santosh, like feel free to add.
It's good to. I want to call that
100%.
out.
It is, and we don't have like we don't. These are not currently emitted. Like if you go create managed private endpoints, I got the community was super vocal about like enabling this for all SKUs, and
I was one of them. That's why I'm pointing this out. I want to make sure this is something I think the community fought for, and I want to make sure that we are clear about this. Like, look, this stuff just works with Fabric, and it's built in at any. Now, correct me if I'm right. Any SKU level. We're not talking like this is like an F64 gated thing. This is at F2 all the way up. So like, you want to use it, it's available, and I think that's very important because the community was very vocal about this feature. Me being one of those vocal pieces, trying to really push for this. So this is great. I love this.
Totally, and we currently the network costs don't show up. Like if you go to your capacity metrics app, you don't see the network cost, but it's something that we're working on. It's currently not being reported, but you would start seeing it based on the managed private endpoints that you have provisioned, or like the tenant private links that you've tenant level private link that you've enabled.
Mm-hmm. Awesome. I just wanted to point that out. Sorry, I didn't mean to interrupt there. I just wanted to make this is a really important point that I want to point out to people.
Yeah, no, that's really great, Mike. I think that's a great point that we initially had that F64 restriction, but I think we heard all of you loud and clear, and it's now been lifted and it's available to all SKUs. Cool. So I think just extending there, I think the last point is that with the provisioning of managed private endpoints, it also allows you to access data sources that are restricted for public access, right? So from your notebooks, you always want to mash up as much data as possible, but there is always these finance related data or HR data that's kind of locked up, not available for access to everyone, right? And the availability of these managed VNet kind of provides that secure setup that can be utilized to go access these resources, and then we will touch upon how to do those things in the upcoming slides.
And maybe one more other point here, I just want to point out here, like when we hear managed VNet, we think, oh my gosh, is anything not secure when we don't have managed VNet? That's not the case here at all.
That's not the case,
What we're saying is, Entra ID secures everything you're going to do anywhere in Fabric. That's still a standard bare bone, like it's built with security in mind from day one. The problem here is people are more of a security hole than their networks are. And so what we find is, people share passwords. We don't have MFA turned on. It's the people that are the weakness here. And so the idea here being is, look, you can also include Entra ID. It's given to you out of the box by default. If you want to add to that, any network traffic from anywhere else also can't get to access to anything else, regardless of where that comes from. You now have another added layer of security around that protected data, those Spark clusters. It's now in a network that has limited IP addresses or limited network traffic that can come directly talk to those machines and even speak to them. So it's another layer here around of security. And this is always a game we play. We play this game between more secure, less access, more access, open things up a little bit. So it's a game we play, and your organization will have policies around this, or you may not. And this may be a place where you can implement some new policies around securing your data. So again, I just want to be very clear. This supports the smallest businesses who are just getting going, all the way up to the enterprise businesses that have policies and procedures and entire teams around a network security team. This stuff will align with your existing infrastructure. I just want to make that point as well.
Yeah, absolutely. That's an excellent point, Mike. I think thanks for stressing that.
Mm-hmm.
Cool. Awesome. So maybe let's go to the next slide, Santosh. Cool. So, like we discussed the managed private endpoints and the managed VNets providing, the maximum security there is. There might be scenarios where public access to data sets is not completely blocked, right? So, but they're still restricted to some entities, right? And in these scenarios, we offer a simpler option to customers to be able to use what we call as trusted access, right? Which is more of provision a workspace identity, and then ask your admins or the data owners to provide access to this workspace identity, and then that data is just a shortcut away. So this is a simpler option that we're going to double click on in the walkthrough that we have at the end of this section. Cool. So I think moving on to the next layer of security, I think we covered the perimeter security. So now comes access control, right? So you kind of figured out who are these trusted parties that can enter. Then you want to know what these folks that have entered can do, right? So so the notion of workspace roles lets you manage who can do what in a Microsoft Fabric workspace, right? To grant an individual or a security group access to a workspace, all you do is you assign them to one of these 4 roles here: admin, member, contributor, or viewer, right? And internally, each of these roles maps to a set of permissions. With admins having all the permissions, members having a few less, and then contributors having a little less set of permissions, and the viewer role having, I think, the bare minimum set of permissions that allows them to kind of just view artifacts in the workspace, be able to kind of maybe read reports and data that's available to them, right? Now, you don't necessarily want to always share or grant access to the entirety of the workspace. So we have more finer grained controls. I think this is where you see the layering in security, right? Where you first determine who gets to enter your network, who gets access to your workspace, or hey, maybe I don't want to give access to my workspace. I want to just give access to a single artifact. So the notion of artifact permissions and sharing allows you to do just that, right? And even finer grained control where like, hey, I have shared my data. Like it might be a set of like call logs or anybody like calling into your customer care. You probably don't want them to see like all the details about your customers, right? Like the credit cards that you have. So you could have like sensitive data living along with other non-sensitive data in your data assets that are being shared. We kind of like go one step further in this layering of security through OneLake data access, right? So it's a public preview feature that allows folks to kind of like grant permissions and access at a tables and folders level. So you can again like similar to workspace roles, you can create these data access roles, assign users or groups to these access roles, grant them access to specific tables and files, even though you have shared the artifact. But if you set up these roles and policies that a certain class of users can only like read maybe the data from North America, maybe they can only read customer data that is partitioned into non-sensitive versus PII. Right? I think like those policies are definitely configurable through the OneLake data access feature. And I think like we've also been investing into extending this in the future. I think you will see more granular access in terms of a column level and row level security also coming out in the same OneLake data access model. Cool. So I think we've kind of like talked in abstract. So we wanted to take a couple of concrete scenarios and then like describe how you would go about achieving those scenarios in a secure manner, right? So the first scenario we have, I'm just like calling this as a trusted access scenario. So you want to you're in your workspace, you kind of like pumped up to go like do that notebook. But you quickly realize, hey, I want to access that data, but my organization does not give access to that data to everyone, right? And it is behind locked doors, so to say, right? And you have to go ask for permissions to do that. And the way to do this, I think, is through the notion of trusted access, where you can go ahead and set up an identity for your workspace that you just created, and then go to your data admin and ask them to go add Fabric as a resource instance option in the Azure portal, right? So with that, they can select like a specific workspace to give access to, or all the workspaces to give access to. And once that is enabled, like the policies restrict just that Fabric workspace or all the Fabric workspaces in that tenant to get access to that data. And then you're off you go, and then you can just go to your notebooks and then access the data by creating a shortcut in your lakehouse to the data that you just got access to. And it's just the standard process of creating shortcuts. Like you create a connection to that storage account, and then you link it to the table or folder of files that you have. And once you have that, off you go with your notebooks. You can access it with Spark and then get the full power of Spark to analyze that data. Right. So
I like this feature a lot. This taps into like my need of, we've already invested, I don't know, hundreds of thousands, millions of dollars in infrastructure, storage accounts, all the data that we've already built inside Azure. It's there. We need to get it into Fabric as fast as we can. This is a great feature. I love this feature very much.
Exactly. Yeah. I think this was meant to be like a really great way to unblock all the data assets that already exist, like tons of data that enterprises already have, and a quick way to just get access to all of that.
I mean, think about the terabytes of data that's potentially already in Azure, and you like, well, we got to get it into Fabric. You now have to like, copy it over. That's a huge cost. It may not be even the right data center. Like, there's all these implications here that can cause a lot of friction here that I've seen. And I think this is just a great way of removing a lot of that friction point around, all right, great, data's already in Azure. Let's just start connecting to it. This is wonderful.
Exactly. Yeah. I think this is a great way to kind of like quickly get access to your data that already exists and start deriving value out of that. And that's all Fabric is all about, deriving value of your out of your existing data assets, and then generating those insights that help you optimize your business.
Would this be called like that term of like they call it virtualizing your data, right? It stays there and you're virtualizing connect. Okay, good. So just making sure I'm making the right language here. The virtualization of data this is what that's doing, and that's super important.
Excellent. Yeah.
Cool.
So I think like the next scenario we have is a little bit more advanced. I think there is always those data sets like finance data sets or HR data sets that are completely locked down, right? You don't have any kind of like public access possible to those data assets. You don't have any kind of like persistent user access granted to that storage account, right? And access needs to be done through a specific service principal whose credentials are stored in a key vault. And naturally, like key vault also blocks all public access, right? So you have this notion of vault data that should be like completely secure and not accessible to everyone, right? So let's look at how you can go about accessing that data in Fabric as well, right? So the key here will be to use managed private endpoints, because there is no public access, right? So it has to happen through a private endpoint, right? So the first step in this is to go create managed private endpoints to both the key vault and the storage account, right? So the managed private endpoints, as you can see in the GIF, are provisioned on the workspace. And once you do that, the act of provisioning it generates a request on the data admins or the data source admins. So they like you're seeing in the portal, they get to see, hey, someone has made this request. Do I know who made this request? They can go do that validation and make sure they're providing access to the right people. And once they have, convinced themselves that this is the right thing to do, they go and approve the private endpoint access, right? So once that is done, you will see that it shows up in the workspace as, hey, these private endpoints have been provisioned. You can like you're seeing here right now, it shows provisioning when you're creating it, but at the end it moves to a provision state. Once you have that, right, so you now have established, like from your workspace, private connections to both your key vault and your storage account, right? So the key vault is the place where you have the secrets to the service principal that can access the storage account. So we have this nice set of like utilities in MS Spark Utils called credential utilities. So with that, you can connect to the key vault and then like get the credentials for the service principal, and then you just go ahead like you're seeing here, right? At the top is where you got the credential. Then you set up like all the configurations in Spark to be able to read that storage account. The client secret that needs to be used. The mode of authentication is set to OAuth, and then the Spark job is then on its way accessing the files securely through the private endpoints that were connected. No access being made through internet, and using a service principal, which is not a user identity but a service identity that can be access to which can be controlled more easily by those data source admins, right? So so this kind of like gives an overview of two different setups, like one a little bit more simpler, and the other something really advanced, and how easy it is to actually just get access to this data in a matter of like few clicks, and being able to kind of like access and work through that data, I think is really powerful.
And if I had to unpack a little bit what's going on here, there's a lot of clicks. I mean, again, you're saying a couple of clicks here. That screenshot is moving very quickly through the screens there, which I understand. There's a good amount of clicks to get through all this. But at the end of the day, it's really, you start from the workspace level, and at the workspace, you're initiating the requests, tapping your IT department on the shoulder and say, hey, the requests have been sent.
Right.
This has always been, I mean, when I've been building things in Azure, this has always been a challenge. Anytime someone says, oh, we got to add the networking stuff, everyone rolls their eyes and like, okay, we'll do it. But everyone just is not happy about the process. It's so involved and
Right.
things just don't work and slows things down. So the fact that you're really thinking about this story and trying to make it seamless, and especially now with Spark utilities, again, love me some Key Vault. Key Vault's amazing. So the fact that you're giving utilities the ability or more power to get the securities and the keys and the tokens that they need just to work with the service principles, it's great. I mean, this is a much better experience than having to set this all up by yourself and doing it manually all in Azure.
Exactly. I think you hit the point on the nail, right? I think though it seems like it's a lot of friction to kind of like get access to these data assets,
Yeah.
but it's really important that enterprises and organizations like follow that process to protect their data assets,
Yes.
right? So it's natural that there is an amount of friction involved in getting access.
Important. It's all. You also noticed there when you were approving those requests, it was asking you like there's logging on all this too.
Got it.
So the other thing, there's natural logging in Azure. When you approve that request, that is tracked, that is stored, it is somewhere in a log somewhere. That when you need to come back and audit things for like HIPAA compliance, whatever other kind of financial compliance, SOX, whatever, it's there. You're knowing who's been granted access to what data and what elements. So again, this is also very important from a security standpoint. We've got full record of what happened and who's getting access to what data.
Yeah. And I think like the good part about Fabric is we've tried to kind of like, decouple and keep these worlds a bit isolated, right? Ideally you don't want to be like, looking around in your organization as to, hey, who is the admin for this data source?
Mm-hmm.
Right? So I think the ease here is you're still in your workspace, right? Like all you need to do is, hey, I need to like go look up my data wiki, right? Where
Sure.
They say like, hey, here is a private endpoint that you need to create. It automatically generates a request, right? It's all kind of like async, right? You go do one step, they go do the other step.
Yes.
Then you have access, right? And then it's all like available, like nicely packaged for you inside your Fabric workspace.
I love it.
Yeah, so I think
one other thing that I would also want to add to this, right? So the managed private endpoints, it's as you mentioned, like as Shravan also mentioned, it's more, it's becoming more general. Like we started with Spark, now Event Stream is also supported. So you create these managed private endpoints. It's going to be used for your notebook jobs, Spark job definitions, or like now you can also leverage these connections also on like Event Stream, right? So it also ties to the overall Fabric vision of like unified model in terms of like admin capabilities. There is this blog post, I'll post it in the comments from Dan from the platform team on like the recent announcement of like support for Event Stream, which is also really, really cool.
I'll see if I can go find the blog post and sneak it in here real quick. I found one for secure data streaming with managed private endpoints from Alex, I think. So I'm going to put that one in there. And if I find the other one, I'll keep looking for it. So yeah, you're right. Again, if I'm already adding the private endpoint for the workspace, we should just use it everywhere. It should just be easy to turn on whatever we're doing. So this makes total sense to me, especially if I'm going to turn on for one feature. We're going to use it for everything. It makes total sense to me.
Awesome. Yeah, I think like that's most of the content we had for today. I hope you enjoyed it.
Awesome.
Yeah.
Well, this is a great presentation. I'm so jealous because a lot of other people have to go read documents and then go figure this stuff out for themselves. But gentlemen, you give me the opportunity to sit directly with you, ask questions, add my own 2 cents on top of things, and you can tell me I'm wrong and blowing smoke and just a goofball. But I really do appreciate this. And I'll say this from the community side, of one who likes to build things inside Fabric. I'm continually being impressed. I'm continually seeing you guys catch up ground against the market around Spark and things. We know you guys weren't the kind of the first people to land it. You've had Spark for a long time, but we're now seeing really great integration for the business users, turning data scientists, turning data engineers. They're getting a very strong tool, and you're really listening to the community. So I just want to say thank you very much for the presentation. Thank you for letting me be guilty and stealing your time away from all the new feature development stuff. And again, we don't see your team. we want to fully recognize it's not just you, it's a whole team of engineers underneath the hood here that is also producing these great features for you. So thank you, one, for your presentation, but then also back forward to your teams of all the people watching this as well. So make sure you share this video with your people internally. Thank you. We appreciate all the hard work. We love that we're getting better and better products with all this investment. So thank you so much for your time. With that, we'll just say goodbye. Appreciate your time. And until we can figure out another session, let's do some more of these. This has been great. We'll do another one in the near future. We appreciate you, and we'll see you next time.